friends, welcome to Install. So today it is the 81st episode in the science series. So today in science it is physics again. So today we're going to discuss about two of the four fundamental forces. So the four fundamental forces are gravity, electromagnetism, strong interaction force and weak interaction force. Out of these four forces, we already discussed about two, gravity and electromagnetism. So in this episode, we're just going to skip out those because we already explained those. Yes, we already made a video about them. Yes. So now let's start. We're only going to discuss about the strong force and the weak force. Let's start with the strong force. Yes. So yeah. So these are nuclear forces, these two. That means they only act in nuclei of atoms. It doesn't work in anywhere else. We can't feel these two forces, but they are one of the most fundamental and important forces of the world. Yeah, so first let's start. Okay, so you know that the nuclei of an atom is made out of protons and neutrons, right? Yeah. So we just took a random nuclei. Yes, just the nuclei, no electrons, nothing like that. Okay. So wait, we need to add some more neutrons to balance it out. Yeah. So yeah, that's enough neutrons. So now all of these are balanced. So neutrons, they're just normal. They don't have any charge whatsoever. They're neutral. You can see it in the name. But protons, they're positive. Meanwhile, electrons, they're far away, so they can't do anything. So as these protons are literally positive, have a positive charge, just like in magnets, they normally should repel each other. But how are they not repelling each other? How is a nuclei stood together without breaking apart in a big explosion? That means pretty small explosion. But still, how is it still the same? That means joined together without being like separate. The reason is this strong force. So strong force only works in a very small scale, around the scale of this, a very fundamental scale, the size of nuclei only. Yes. So strong force is very strong. Yes, stronger than the repulsion forces and attractive forces of magnets and charges. Yes, that means it can overpower the repulsion forces inside the protons and just fuse them together. Even if they're trying to repel each other, this force will just push them to stay next to each other, even if they don't want to. Strong force is very important to keep all the atoms in a perfect order, all nuclei. So without the nuclei, no atoms, no us, and without atoms as well, no everything. Without atoms, nothing in this world can exist. So this strong force is very important and fundamental for literally everything. Yes, because it keeps the atoms together and without breaking those atoms, just boom, explode. That is a strong force, the thing which keeps atoms joined. Yes. So okay. So next we are going to see the one and only weak force. Weak force is a bit more complicated. Yes. So there are two bosons known as the W and Z bosons. W and Z. I'll represent it like this. So again in the W there are two other types. W minus, W positive. They both are in different charges as well. Yes. So they are just known as the W boson and Z boson. Just simple, nothing else. Okay. So now there are small particles known as neutrinos, which are different from neutrons. We're going to explain that in another video. But neutrinos are very small, more than million times smaller than normal electrons. Okay. So neutrino is symbolized with a V. Okay. So next let's take a normal neutron, N. Yes. So neutrinos just go very fast. We'll learn about that later, but yeah. So one of these forces will work here, one of these bosons. That is, so if the W boson is charged negative, so yes, so this wave-like effect that means the energy here is applied by the W boson, which is in a negative charge for this example. Okay, so immediately this neutrino will turn into an electron with a small charge, that means with a negative charge. Yes, meanwhile this neutron will get a positive charge and turn into proton. Yes, but how does this happen? This happens immediately. So that neutrino will immediately turn into electron because its charge is changed, but nothing happens to the neutron, that means charge wise. But how does it turn into proton without any charges pushing it? The reason is because of the force which is happening here, the neutron is completely restructured and turned into a proton, making it positive, and then this happens, electrons and protons. But this is very important because it can change the literal nuclei of an atom. For example, let's take this nuclei again. Okay, it's just normal. But because of the things which are happening here, these protons can also turn into neutrons if it is a W plus boson happening. And electrons can also turn into, you guess it, neutrinos. So that can also happen. It can be completely reversed again. So that is very bad. So normal protons here can turn into neutrons, making this nuclei not normal but an isotope nuclei of another element. And again another proton is changed. And again another proton, making it more unstable and more unstable as it goes on. This is the reason that radioactivity even exists. This weak force is the cause of radioactivity. Why protons or neutrons are just thrown out, especially just neutrons are thrown out when in a very unstable particle. This is the exact reason why that especially happens. Yes, yeah. So yeah, this is for today about the two of the four fundamental forces, the strong interaction and the weak interaction. Bye.